export on this computer. Okay, so just to briefly recap my welcome. So yeah, we're going to go over the Lucene changes from the past 3 weeks. And yeah, let's get into it. So the one I was talking about at the start of the meeting was this one with this index input prefetch. So why is this one exciting? Well, I was discussing it with Saurabh H, who was interested in doing something like this. The way that it's been, or the motivation apparently for it being added in Lucene, is related to page caching and memory mapping. So, as you can see, yeah, this is the more relevant benchmark because it's after adding madvise to the mmap directory, or yeah, using madvise on the mmap directory to sort of help with prefetching. Because yeah, the initial benchmarks that Adrian found with enabling this prefetch. So before seeking to specific bytes in a Lucene file, it would say, I am going to seek to this byte. As you can see, when the data does not fit in the page cache, prefetching, ballpark seems to cut the load time, the latency by about half, right? Like the P50, going from 103, or sorry, from 226 to 103, and even the P90, yeah, ballpark half-ish from 247 to 144. But that he found that when the data does fit in the page cache, so it's easily mapped anyway, that it looks like the prefetch did add a little bit of overhead, but it's where Robert's suggestion to use madvise seems to have essentially eliminated that. So when the data fits in the page cache, that you have it's essentially no latency. Like obviously, without prefetching, it's literally 0 microseconds. And okay, so you get 1 to 2 microseconds with prefetching. But as you can see, when the data does not fit into the page cache, again, the prefetching helps quite a lot. This is, well, even the P90 in this case, it's closer to twice as fast. So the reason why I'm excited about this, Saurabh's excited about this. This is paging from disk into available RAM, into the file cache. But what if you're paging from not disk, but a remote store? Right. So the way that our remote store implementation in OpenSearch works is by using a custom directory implementation that will go and fetch these chunks. I believe they're 8 megabyte chunks from the remote store. They get copied to the local disk, and obviously, just like with this. If you can prefetch them so that they're there before you start to access that stuff, then yeah, you don't have this delay. Where that's exciting is, of course, these numbers of paging from local disk into RAM are measured in microseconds. When you're paging from a remote blob store onto local disk, you're talking milliseconds into, well, potentially triple digit milliseconds, sort of approaching, single digit seconds. But yeah, so obviously this kind of prefetching, yes, very useful when you're talking about prefetching from local disk into page cache, but also you can apply the same thing when prefetching from remote. So very, very exciting. But it's coming in Lucene. Unfortunately, it's coming in Lucene 10.0, which so for us on OpenSearch, we potentially have to wait for OpenSearch 3.0 to really benefit from these APIs. But yeah, at least we know it's coming. And so if we wanted to add some prefetching into the 2.x line, we could hack it in for now, just knowing that something better is coming. Yes, Andre.
Yeah, Michael, I just want to ask, so this prefetch hint should come from someone else. I mean, not from Lucene, but Lucene, it has to be told Lucene, okay, you need to prefetch. And
yeah,
where exactly this decision happens, and who will do this?
Right. So actually, what's happening in Lucene now is, sorry, yeah, I should have gone to the top level issue. So, yeah, so Adrian's making changes in Lucene itself, and this is where I think some of us should, some of us working on OpenSearch who stand to benefit quite a lot from this, because as I said, for remote store, it's going to be very helpful, I think. Yeah, Lucene itself. So the higher level constructs, the codex. So the codex talk to the index input, which is provided by the directory implementation. And so, yeah, in this case, with the term dictionary lookups, yeah, I skimmed through this change yesterday, but where was it? Term denum. Yeah, so in the implementation of term denum, no, sorry, that's related to the base term denum. Yeah, so essentially, yeah, so it's adding in this prepare seek exact. So prepare seek exact was inherited from, what does base term enum inherit from? From term enum. Okay, so yeah, term enum adds prepare seek exact. So essentially, like before you seek to a term, you say, I am going to seek to this term. And I believe that then in term query, yeah. I'm not sure where yeah, okay, so in the scorer supplier. Well, actually, where does it do the prepare seek exact? I suspect.
So seek exact, but not prepare. Yeah, seek exact around here on line 181.
Yeah, possibly the hook to call prepare seek exact isn't there yet.
Yeah,
probably. But yeah, just kind of yeah, so this is actually kind of interesting that this call to get terms enum has been moved into the scorer supplier constructor. Oh, well, yeah. Okay, so yeah, so it's not until you call get that it invokes get terms enum. But yeah, yeah, that's actually a good question. Where does it call the prepare seek? So there are the implementations of prepare seek exact. Okay, so check index. Oh, okay. So okay. So it looks like, yeah, this is just if this is the only place it's actually called, then yeah, I think that is the case. So oh, term states. Aha. Okay, so yes, when we build term states, this, yeah. Where'd it go? I lost it. So yeah, term states build. Yeah. Okay. So this one, will actually prepare seek exact for the terms in a term state. Okay, cool. Yes. Okay, so this makes sense. So as it seeks through all the leaves, it says like, oh yeah, I'm gonna preload the term dictionary for this field in each of the leaves. Yeah, or for this term, sorry, in each of the leaves. Yeah, this is based on a single term. So okay. Anyway, yeah. So the prefetch is a pretty significant change, and yeah, I noticed that so we don't have an issue for doc values yet. I believe so there is mention of stored fields. Um, but yeah, doc values, stored fields still need to be implemented. And so yeah, I'm kind of interested in trying to pitch in, or suggest that other people try to pitch in, because yeah, the sooner this capability gets out, well, obviously it'll wait for 10.0, which is planned for October. But yeah, if we can get it in and help, that'd be great. Cool. So, yeah, the I was so I was skimming through the other changes. This one actually is very cool. With the improved compressed int4 quantized vector search. So this one. So everything I've heard about the performance of int4 vector search suggests that it's very, very fast. Yeah, so as mentioned, it gives us an 8x reduction over float 32. Well more than 2x faster queries than float 32. And yeah, so these half byte vector searches seem to be extremely fast. So very, very exciting. And of course, being able to do it with SIMD, of course, very, very exciting. Yeah, I suspect that chances are, well, actually, yeah, we can look at the path of the file changed. I'm kind of curious. Yes, yeah. So chances are, it probably depends on using Java 21. Yeah, because it does make use of some of these Panama APIs. So, but Andre, do you know? So have we upgraded to JDK 21 by default? Okay.
Yeah,
Yeah.
we bundle it.
Okay. Okay. Because yeah, I remember there were some issues where people were complaining of uh much higher heap utilization since the upgrade to JDK 21. I don't think we've managed to get to the bottom of that, have we?
We did not. Yes, we did.
Okay.
Still, there's ongoing discussion, but we didn't get to the bottom of it. That's correct.
Okay, because yeah, I also remember there was an issue where somebody was running a benchmark. So they were benchmarking JDK 21 specifically. Not they were JDK people who were benchmarking JDK 21 and using Lucene as part of their benchmark. They had these da capo benchmarks, and they were seeing what they believed was a performance regression with Lucene, starting with Lucene 9.7, related to the Panama mmap directory, stuff. And so yeah, they started to raise some alarms, saying like, hey, there's a major Lucene performance regression with JDK 21 starting in Lucene 9.7. And it turned out that the benchmark was really aggressively opening index readers, which you shouldn't do, right? Like it was reopening the same index reader, like no changes to the segments, uh, and just kind of opening them many times per second. So yeah, it was eventually deemed to be a mistake in the benchmark. And yeah, once they removed that and kept reusing the same index reader for um, for multiple calls, things got much faster. Um, so, but yeah, okay, that heap usage thing. So we still haven't gotten to the bottom of it, but it also seems to be somewhat sporadic in terms of people finding it, because obviously, like our benchmarks haven't turned anything up. So yeah, we'll have to keep an eye on that. But yeah, anyway, with JDK 21, obviously, yeah, things like this SIMD optimization for the int4 vectors is pretty exciting. So, kind of continuing through, yeah, this I was also somewhat curious about this one, um, where this feels to me like a surprisingly significant change, um, which is that the Lucene query cache uh, wasn't using a reentrant read-write lock. It was just using a regular reentrant lock. Um, and yeah, I'm actually kind of surprised that this kind of stuck around for as long as it did. That yeah, it looks like um, essentially what was happening was that yeah, so multiple threads reading and writing from the Lucene query cache could get blocked on each other, which yeah, I think is kind of surprising. Um, but yeah, using the reentrant read write lock, obviously you can have multiple concurrent readers who aren't getting each other's way. Um, as you can see from the benchmarks listed, yeah, when you have a low cardinality field, um, yeah, that they managed to get sort of a doubling of QPS in this benchmark. So yeah, that's pretty exciting. But yeah, no, I was just kind of surprised that because the Lucene query cache has been there and in that state since I want to say 2016, I think, maybe 2015. So yeah, I was just kind of surprised that um, the use of the reentrant lock, but not the reentrant read write lock, persisted for yeah apparently probably 9-ish years, 8-9 years. So yeah, but no, this is a nice improvement.
I believe, Mike, the story is that I remember that historically red light lock had pretty bad performance.
Okay.
In some GDKs, maybe. Yeah, definitely changed recently because there are many improvements going on, but it was very much discouraged to some specific up to some specific version probably to use them just because of performance.
Really?
Were not great.
Okay.
This is what I remember from them, but probably everything changes so fast, and it probably makes
Yeah.
sense already to use.
Oh, I didn't realize that. Okay. Because yeah, the times when I've used rewrite lock have been not, yeah, so something like the Lucene query cache, this is right when you think about uh how these calls to the cache work, right? Like imagine you've got this big hairy Boolean query with lots of subclauses, and each of those subclauses have subclauses, and each of those subclauses have subclauses, right? When you call create wait, right? Because the Lucene query cache kicks in on the index searcher dot create wait call. That index searcher, actually, I can bring up the code because Apache slash Lucene. Yeah, because it's actually a super simple method that all symbols filter create. Yeah, create wait. Yeah. So essentially, if the query is non-scoring, so if it's under a filter clause, whatever, right? Then it'll call wait equals query cache dot do cache. Where then the query cache will ask, is this wait cacheable? It doesn't make sense to cache a term query, for example, just because the term query's representation is its postings list, which is written on disk as that postings list, right? So there's really no work involved in like recording that bit set for the postings for a term doesn't really help, right? Because it's the terms on disk and the which are going to get memory mapped are essentially identical to the bit set that you would create. But if you have a more complex query, storing the pre-computed bit set is handy. So as it goes through the whole query hierarchy, this call to query cache.do cache is actually happening on every node in that tree. Right. And so you can imagine that, when you execute a query, there may be, like 100, or more of these calls in very quick succession. And of course, if you're running, many queries in parallel, across multiple threads, they're all calling this query cache.do cache. So this is where I could totally see how if re-entered read write lock had some bad performance, calling it really heavily like this probably wasn't great. But evidently, if it performs well now, the fact that you don't have these threads stepping on each other's toes is nice. Particularly when they're able to load a value from the cache rather than adding something to the cache. So yeah, yeah. So while the list is relatively long, those were the ones that kind of jumped out at me. I suppose this one with the new vector scorer interface. Unfortunately I didn't look through this one ahead of time. I don't suppose anyone here is vaguely aware of this one. I
No, definitely not.
uh, yeah. So the just kind of skimming it. Yeah, like I'm kind of wondering. So my vague impression, or so I'm not very well versed in how the Lucene vector search stuff works, but I poked around a little bit in the KNN query, and I get the impression that the KNN query does a lot of its work, um, sort of upfront, like before the query executes, the query has executed, if you will. Like I believe, I could be mistaken, but I think at least it was the case that the KNN query was doing pretty much all of its work in the rewrite method. So when you do the query rewrite, it would say, "Oh, wait. Let me go into the sort of into the graph, the HNSW sort of layers, and I'm going to go find the nearest neighbors to this target vector." And then after it's rewritten, it's essentially rewritten as a kind of static doc ID set. Um, where it's like, okay, here are the pre-computed doc IDs of vectors that are, within K distance from the target vector. So that's for the approximate nearest neighbors. I'm wondering if this is something related to more, kind of be able to actually iterate through vectors of increasing distance from the target, or yeah, I'm not sure. But I was under the impression that at least the approximate nearest neighbor search is pre-computing up to K, and that's it. That's all you get, right? Because it finds the nearest K, and then that's your doc ID set. But I could be wrong. So yeah. Does anyone want to look into this in more detail and report back next time? Failing that, I can go and we have people who work on OpenSearch who are who very closely follow the ins and outs of Lucene's vector APIs. I can ask Navneet sometime if he's aware of this, and he can tell me what's going on. I can invite him to come back and explain it to us. So yeah,
that would be good, I guess. Yeah, because it seems like interesting, but needs a little bit more knowledge to understand exactly where it fits to OpenSearch.
Yeah, actually, you know what? I'm going to mention Navneet. Yeah, so this is something mildly annoying. Okay, there. So at yeah, this should be Navneet. You know what blah is doing? It sounds cool, but it's over my head. Yeah, maybe. Yeah, because that.
Nice one, Michael.
Well, yeah. Well, because again, yeah, Navneet tends to know this stuff pretty well. Yeah, again, it sounds cool, but yeah, I'm not immersed enough in vector land to fully understand what's going on there. So yeah, otherwise, yeah, it's obviously, there are more and more of these little changes where people are making use of the caret HPPC, the high performance primitive collections. Yeah. Just avoiding object allocations, which is nice. So yeah, each of these, every time I see one of these types of commits, it's like, yep, it's probably just chipping away a tiny amount at the number of object allocations, which each one on its own probably does next to nothing, but in aggregate, I'm sure they do have a pretty significant impact on the number of objects being allocated in Lucene, which always a good thing. Less garbage collection. Yeah. So yeah, that's pretty much the the past 3 weeks in Lucene changes. I didn't prepare any other topics. Did anyone have something that they'd like to talk about on Lucene?
So Michael, I just want, if you don't mind, to go back on this HPPC stuff. HPCC, right?
HPPC, yeah.
Yeah, the current one, yeah. High performance.
Yeah.
Blah, blah, blah. Because
yeah.
we used to have more of them in OpenSearch as well, all over the place, and then we started to replace them with just Java, not equivalents, because they're not equivalent one. It was just Java primitives from standard library, maps and all that, and I don't actually know, because this library was released, the last release is 4 years ago.
Right. Now
something is happening, but
Now that said, for the most part, my understanding is that the collections are there. They're done, right? So like the int object map, for example, I suspect is probably not really a map, but rather an array or something. Or probably arrays of arrays or something like that to avoid or potentially I've never actually looked into it, but the upshot of it is I think that for the most part they're just kind of done, I think. What was it?
It's just
or I can't even find the int object hash map. But so that's interesting though, that in OpenSearch, I wonder if Nick did that to just cut down on the number of dependencies, right? Because it's just another dependency. I could also totally see how at the OpenSearch level, except in some very specific cases, I think using primitive collections is probably a premature optimization, right? Just because so at the Lucene level, when you've got these a lot of these like really tight loops, right? Or think about how analyzers in Lucene make extensive use of like reused byte arrays. So when you tokenize some text, with Lucene, it per thread it allocates a byte array for the at least the field being analyzed. And as it steps through the tokens, it's just updating the contents of that byte array so that it basically never gets garbage collected because it's just reusing the same byte array. So that kind of thing where Lucene, having these like super tight loops where the same stuff executes like a million times as part of a query. Obviously any object allocations that you could avoid are going to be very useful. In OpenSearch, we allocate so many objects, when you consider just, deserializing a request, constructing objects in order to serialize them out as a response. Honestly, there's probably not a lot of cases where a primitive collection is going to significantly impact heap utilization because we're allocating so much garbage all the time. So
this is not an excuse, but I agree with
you. Yeah.
I mean, one of the concerns also was that it's kind of stuck in time, as you can see, and that was also depending on libraries which are not actually evolving anyhow. There's new releases, there's no active maintenance. That's also a risk.
Yeah. Well, the other thing, of course, is that it's not API compatible with Java util collections,
Yes.
right? So yeah, and frankly, Java util collections API compatibility is kind of handy, right? Being able to well, yeah, just the fact that you get access to all the helper methods in the Java standard library, right? In the Java runtime, right? So think about like, oh, I want to do a stream filter collect on a collection. It's like, well, yep, that's built in. Whereas so far as I can tell, you can't do that with these HPPC collections. So yeah. Yeah, cool. So anything else? If not, yeah, we can probably wrap up a little bit early. As I mentioned up at the top, you know, eventually I'd like to move these back to Monday morning, but this past week, of course, Monday morning was a holiday in Canada and chunks of Europe. This next Monday is a holiday in the US, and so like I'm going to be off this next Monday. But so yeah, so probably next week Thursday again is when I'll schedule the next occurrence of this meeting. I'll try to have a topic lined up. We've got some things that we've been some of us have been thinking about in Lucene land, things related to concurrent search, things possibly we can ask Bharadwaj to come and talk about this star tree index that he's been playing around with. And proposing getting into Lucene, there's still some negotiation there. I can kind of see how maybe it doesn't belong in Lucene because it's not really a search thing. Another topic actually potentially could be aggregations and Lucene facets, because we also have some ongoing discussion. Sandesh has been engaging a little bit on this Lucene issue that Shraddha opened. Facets. Yeah. Identify gaps in Lucene faceting Lucene 12553. So yes. So yeah, Sandesh commented 4 weeks ago, I guess. Yeah, suggesting like, hey, we have OpenSearch aggregations that are much richer than Lucene facets, but on the other hand, yeah, Lucene facets also have some pluses. So yeah, maybe we can talk a bit about aggregations and facets next time if people are interested.
So, Michael, just a quick question.
Yeah.
And maybe I should know this, but is OpenSearch using Lucene facets?
No.
Right. So
no.
Who actually really uses Lucene facets?
Right. So I know that Amazon Product Search does. So Amazon Product Search makes extensive use of Lucene facets, and that's actually where a lot of the Lucene facet development is coming from these days. By the looks of it, is so Stefan Vodisa works on Amazon Product Search, and he's been contributing some facet related stuff. I actually made a small change a couple months ago to avoid reallocating all the taxonomy ordinals. When you add, it was the case before that if you added one new taxonomy ordinal, all your arrays would get fully reallocated, which if your arrays are very big, would create a fair bit of GC churn. The idea here would be if we OpenSearch could start to push some of our aggregations logic down into the Lucene facets module, then we could adopt that. To some extent, if if we on OpenSearch could get out of the aggregations business, that would be very nice, right? Because not like, oh, hey, we made this Lucene's problem, but more that it becomes a collective problem rather than tens of thousands of lines of code that we have to maintain on our own, that we can share it more broadly.
Right, understood. And I haven't delved into Lucene facets, but in depth, it used to be that it required pre-building a bunch of stuff at index time, right? Is that always the case, or are there some things like doc values that it can leverage without?
Yeah. So and actually, Stefan's been doing some great work in terms of code reuse there, because so there are facet implementations of the facet APIs that'll just use doc values. It actually behaves quite similarly to OpenSearch and Elasticsearch in that regard, because that code, which I could actually, if I'm already on the Lucene project, the search should work. I want to say sorted set doc value facet counts. Yes. So the catch is, because there's always a catch, is that it ends up pre-computing global ordinals. Of course, while I pull it up, I won't be able to find it, I'm sure. But yeah, there's this somewhere in this there is, it may be. Of course, I'm not going to be able to find it now that now I put myself on the spot. But there's this use of, it's probably here in sorted set doc value reader state, I think. So there's this use of multi doc values somewhere, which essentially, all of these multi whatever classes in Lucene. There's a multi terms, multi terms is the other one that I know of off the top of my head, that basically makes it look like your term dictionary across all segments is one big term dictionary. And similarly, this multi doc values, before it does any processing, it goes across all the segments, gathers up all the doc values into this one big global ordinals mapping, which is not cheap. Now it's cacheable
that's at index time, or is that?
That's a query time. Yeah. So
right. So you have to keep the cache around for performance. Yeah, sure.
Exactly. Yeah. And OpenSearch has the same problem. That there's all this OpenSearch code around global ordinals and caching global ordinals and invalidating that cache on refresh. And that we have this. You could configure for your fields in OpenSearch. You can enable, like at least for keyword fields, there's this eager global ordinals property that you can set, which basically says on refresh, I want you to go and load the global ordinals before making the index searcher available, so that like you're still taking the hit at read time, but you're taking the hit on refresh. Versus so
you effectively, you'd have some warming queries to
pretty much,
so the first person doesn't doesn't suffer. Sure.
But
same in Solar, and Solar of course eschews Lucene facets as well.
Well, because actually Solar doesn't Solar have its own, Solar has two facets implementations from what I remember.
Yes.
Yeah, because it was sort of, there was the classic, I think Solar's first facets implementation was like the first facets implementation.
It's like a filter cache of bit sets, basically.
Yeah. Yeah, and then like Yannick went off, and when he was off doing what was that? He tried to do his sort of reimagining of solar for a couple of years.
Yeah. Not even going to say the name of it, but yeah, you're right.
Okay. Yeah, yeah. But yeah, and then yeah, he came back and he was like, well, I've decided to drop that project, but by the way, here's the facet implementation that I did for it. That's much better than Solar's old facet implementation, or much richer. So
yeah, JSON facets, I guess, is what he called it.
Yeah, which actually are conceptually quite similar to the aggregations in OpenSearch and Elasticsearch. So yeah. But yeah, that said, the Lucene taxonomy facets are interesting because they do shift that global ordinal computation over to indexing time. Which, like most things in Lucene, it's like, well, being able to do a little bit more work at indexing time in order to save yourself work at search time is usually not a bad idea. So yeah, so that's where I would honestly love to if we could at least offer that as an option in OpenSearch to be able to say, you know what, maybe by default we're not going to do the index time work because yeah, it will slow down indexing, but depending on your use case, maybe it's worth it. And give people the choice.
All right, awesome, Michael. I got to drop, but thank you so much. Thanks for helping me out there.
Oh, thanks. Yeah, thanks for coming, and yeah, hope to see you again.
Keep it going.
Thanks. Cool. Okay. So yeah. I think facets and aggregations will probably be a good topic for next time. Yeah. Again, before we go, anyone else with any questions, comments?
Michael, do you know what's happening with 9/11? I don't see release log. There was some discussion.
No.
It's quiet now.
Yeah. Well, so Ben Trent, the guy who's been doing all these amazing vector improvements, he sent an email last week. Maybe, yeah, I think it was last week, saying, hey, we've got a bunch of stuff coming. Yeah, maybe it's time to do a 9/11 release. And in his email, he said, I may be jumping the gun a little bit here because I'm about to go on vacation for 2 weeks. But when I get back, I'm willing to be the release manager. So
okay, got it.
yeah, so yeah, basically Ben Trent is on vacation. A much earned vacation after all the stuff that he's added to speed up vector search and add capabilities to vector search. So
thank you.
Yep. Yeah. So I think, if I recall correctly, I think he targeted putting in an RC build next week. I think it was May 28th. So yeah. Okay. So chances are Lucene 9/11 probably should be out by the end of next week, I guess. Unless something goes wrong with the RC, but yeah, doesn't usually. Cool. Thanks. Okay. Well, thank you, everyone. And yeah, we'll
great one. Thank you, Matt.
See you next time. Bye.
Thank you.